Welcome to my YouTube channel with another episode of Biopython. In the previous lessons, I have done the basics of Biopython. Let's revise a few things. Bismillahirrahmanirrahim. Biopython is a package with the name Bio. It's actually a folder that contains these subpackages and these modules and files. In our last lesson, we have used the Seq module of Biopython in detail. The rest of the modules and packages will be introduced in my upcoming lessons. So these modules, among which I did the Seq module in my last lesson, this Seq module contains these functions and these classes. I have already uploaded a video about functions highlighted in yellow color. Other functions are rarely used by bioinformaticians. Among the classes, Seq and mutable Seq classes have already been discussed in the previous lesson. As you know, classes have methods. Seq class contains these methods. We have studied the yellow highlighted methods in the previous lesson in detail. In my today's lesson, we will discuss the rest of the methods. I will teach you some more things about some other methods as well. Before using any method of a class of a module, we need to import that class first. Whether you import a class or a module depends on your choice and objectives. If you import a module, it will be useful in cases where you are not limited to using a single class of that module and you want to use different methods from different classes of the module. As today I am only using the methods of Seq class of Seq module, therefore I don't need to import the module as a whole. I will import the class directly. Remember, you cannot import a class with this method. It will give an error. You will have to use this syntax for importing a class. As I told you in my previous lessons, there are three ways to see methods inside a class. The first one is dot method. Type class name and put a dot. Methods list will appear here. In the second method, you use dir command to see the list of methods of the class. In the third method, you use help command to see all the methods of the class with their detailed explanation as well as with examples. Here I show you all these three methods practically. Here are the methods. These are the methods. Here is the detailed explanation with examples. Let's now come to the use of methods. These two methods will tell you about the case of the sequence. Is_lower is used to see whether your sequence is written in small letters or not. Similarly, is_upper will tell you if it is in uppercase letters or not. Here I show you two different methods. In the first method, I import the class. In the second method, I import the module. There are two sub-sentences in each of these two methods. Here is the shortest direct method
to see if the sequence given is in uppercase or lowercase.
This method is a little longer. You will have to type bio.seq.seq completely because you have not imported the class. Here is the practical demonstration of this method. This one is the standard method where you save the sequence into a variable mySeq. Then you do further operation on that variable. You type the variable name, put a dot, and put a method. You will get the output. This is the longest method among these four methods. Its syntax is just like this one. The only difference is to save the sequence into a container. These are not the only four ways. There are several more methods through which you can achieve the same objectives. And here is the practical demonstration. Now let's turn to these two methods. Remove prefix is used to remove a specified part from the left terminal of a protein or a nucleotide sequence, while remove suffix will remove a specified part from the right end of a sequence. I am importing the Seq class again and again so that it sits firmly in your memory. Otherwise, you don't need to load it every time. You need to import each class only once at the start of each session. Let's suppose we have a sequence ATCG saved in a container called mySeq. To remove a part from the left end of the sequence, type this command. The result is saved into a container called output. Now print the output. You can see that A has been removed now. Now remove TCG from the right terminal of the sequence with this command. When you print the output, you will see only A because the rest of the part has been removed. There is an option in these two commands and some more upcoming commands called inPlace. If the value of inPlace is false, your mySeq will not change. The modification will only be saved in the output. However, if you make inPlace as true, then mySeq will also be modified. Let's first try it with false. You can see that mySeq has not changed, but the output has changed. Now let's try it with true. It will give you an error. Why? Because you cannot make changes in Seq class objects. They are immutable. For this purpose, we have another class called mutable Seq class. If you create a sequence with mutable Seq, then inPlace equals true will work there. First, let's see the practical of this part. Let's now import the mutable Seq class. Create a sequence and save it in mySeq. Remove a part from both the ends without using inPlace option. Let's now use inPlace as false. Again, no change in original mySeq. But if you use inPlace as true, you will see that mySeq has also been modified. Now let's see the practical demonstration. Our today's next commands are split and rsplit. Although the use of these commands was shown in my last video, but in today's lesson I am going to show you the use of an additional option of split command, and that option is called max split. The default value is -1, which means split at all the places where the symbol given in the SIP option is found in the sequence. If its value is +1, it would mean cut the sequence only at the first place. 2 means cut the sequence at the first 2 places from the left side. In case R split, 2 means cut the sequence at first 2 separators from the right side. Now let's see its use. Import the Seq class, create a sequence with Seq class and save it in a container mySeq. Now cut the sequence at dash symbol only at first position from the left. For this, use this command. Save the result into a container called output. Print the output. The sequence will cut like this, and hence you will get 2 sequences splitted at the first dash symbol from the left side. If you want to cut the sequence at only the first place from the right side, then use rsplit command with max split value of 1. Here is the practical tutorial. Okay, what about searching a specific pattern or a specific subsequence in a main sequence? For this purpose, you use search command with an option sub. Here you will provide the pattern you want to search in the main sequence. The standard method is to enclose the pattern in square brackets. Otherwise, it will not give the intended results. You can search for multiple patterns in the same command. As you can see, we are searching here for 2 different patterns. The first pattern is to find the letter A, and the second pattern is to find the pattern AT. Remember, you type your pattern in the form of a simple string or in the form of a sequence. Import the Seq class, create your sequence. Now search for the letter A and the letter T. Here we are searching without the use of square brackets. In this way, it will search for both the letter A and letter T separately. The output will contain the results of both the letter A and the letter T wherever found in the sequence. It will show you the position of all the A's and T's in the sequence. To see the output, you cannot print it directly. You have to use the for loop command to see the output of search command. If you want to search for the pattern AT, then you must use square brackets. Otherwise, it will search for A and T separately. Here, the result will be like this. It will tell you the positions of all AT patterns. One is at position 0 and another is at the position 12. As I told you that you can write your pattern both in the form of a string as well as in the form of a sequence object. In this example, I have written my sequence in the form of a sequence object. The result will be the same. Here is the example of multiple pattern searches. One is AT pattern as a simple string and another is CG pattern in the form of a Seq object. Here is the result. Now let's see it live in Python. Our next commands are count and count_overlap. These commands were also shown in the last video. In today's video, I will tell you about two additional things of this command, the start and stop options of these commands. The option sub means the pattern you want to count. Let's count the letter A in the given sequence. The result is 3. Now let's count the pattern TCG with count_overlap. They are also 3. The start and stop positions tells Python the boundaries inside where the pattern to be counted. For example, here it means that the pattern TCG is to be counted between 1 and 7. Position 0 and positions after 7 will be excluded from the search. You already know the difference between count and count_overlap. I have explained it in detail in the last video. Let's see it live in the Python. Find, rfind, index and rindex finds the pattern's positions in the given sequence. These methods were also taught in detail in the last lesson. Here, the two additional options include start and stop, which sets the limits or boundaries where the pattern given in sub option needs to be found. Remember, it will only show the position of patterns found at first position. It will not show all the positions where the pattern is found. Let's find the position of first letter A in the given sequence. The first A is at position 0. Now let's set the boundaries from 1 to 5. The first A is found at position 4 inside the boundaries set. Index means the same thing. rfind and rindex gives the position of letter A found at the first position from the right side inside the given boundaries set with start and stop positions. These commands tells us about whether a sequence starts or ends with a desired pattern or not. The start and stop positions sets the boundaries where the desired pattern needs to be looked for. For example, we want to know whether the given sequence starts with A or not. It says true because the letter A is found at the left end of the sequence. But if you set the boundaries of 1 and 3, then it says that it doesn't start with the letter A because we see it starts with the letter T, not A. Ends with will tell you whether a given sequence ends with a desired pattern or not. It means on the right side. For example, it says that the sequence doesn't end at the letter A. Also, if you set boundaries of 1 and 4, there too it doesn't end at the letter A. Now let's see the practical. Translate method translates your nucleotide sequence into a protein sequence. There are several codon tables. The default table of codon used is standard one. Your sequence will be translated based on the standard codons. There are several codon tables. The default table of codon used is standard one. Your sequence will be translated based on the standard codons. You can use a different codon table if you want to translate your sequence using other kinds of codons. You can use table equals 1, table equals 2, table equals 3, etc. for different kinds of codons. The stop symbol is used for stop codon. Here it will represent the stop codon with asterisk whenever found in the sequence. To stop is false, means it will translate the whole nucleotide sequence even beyond the stop codon. However, if it is true, the sequence will be translated till the first stop codon and the rest of the sequence will not be translated. CDS, if it is true, will only translate the sequence if complete coding sequence is found in the given sequence, which means there is a start codon and a stop codon found in the sequence, and the sequence is not short, means it will translate that part of the sequence where distance between start and stop codon is maximum. Let's translate this nucleotide sequence using these options. Use table number 1 for translation. Here is the translation. It is the protein sequence. Now let's do it practically. At the end, let me show you some mathematical operations used with sequences. For example, you have created these 4 sequences. You want to see if one sequence is identical to another sequence, then use double equal symbols. This will tell you if they are identical or not. Because seq1 is identical to seq2, hence it says true. This will compare the first letter of the sequence, as seq1 has A in the beginning and seq3 has T in the start. And we know letter T is greater in ascending order than letter A. So sequence 1 is smaller than sequence 3. It's not greater, hence it's false. Using square brackets will extract a specific position from the sequence. Here we see that at position 5 we have letter C in the sequence. If you want to add 2 sequences, use plus symbol. Here we add NT with seq1. To repeat a sequence several times, use asterisk symbol. Here we multiply seq1 with seq2. Hence, it will be doubled. If you want to see if a specific pattern is inside a given sequence or not, then you can use the in option. Here we see if ATC is found in sequence 1 or not. It says true. Now let's see the practical. So that was all for today. Thanks and bye.